we see, therefore, that when H decreases from the surface here down to the bottom, pressure increases by rho GH. If we apply Bernoulli's equation, which for zero velocity tells us that the change in pressure will be the negative of the change in rho GH, we're going to get exactly the same result. So if state 1, let's say, is the top of the water surface here, where the pressure is, I say here pressure is 0. That's not a very good idea, really. Pressure is atmospheric here. Gauge pressure is 0, and you might think of the difference between gauge pressure and absolute pressure. In any case, that's not going to make a lot of difference in the result down here for measuring pressure on the gauge, and that is valid. You can use gauge pressure with Bernoulli's equation. Since we're talking about simply pressure differences, you can set the pressure equal to 0 at any point you wish. In any case, if we set the pressure equal to 0 here, and the height is of course h, and we note that the velocity is 0, assuming that the velocity of the fluid's not decreasing very fast, and assume the water's just kind of sitting there. So the depth of fluid is not increasing fast, there's no significant velocity. Down here at the bottom of the pool, we also assume no significant velocity, but of course we know from what we just saw that pressure is rho GH and height will be 0 here if the height is h here. So what does Bernoulli's equation for V equals 0 tell us? Well, in the first place, if V is 0, then the 1/2 rho V squared term is 0, and we can say that the pressure plus rho GH is constant, which is consistent with saying change in pressure is a negative change in rho GH. Then our change in pressure, P2 minus P1, is going to equal the negative of the change in the rho GH, directly following from Bernoulli's equation. We could write this out explicitly. We could say rho GH1 plus P1 equals rho GH2 plus P2. That's an expression of the fact that this is constant. And that's entirely consistent with this, which is entirely consistent with what we've seen. So Bernoulli's equation tells us the same thing that our usual means of determining pressure at a depth tells us.